All right, my friends, let's get started. Depending on your experience with conic sections in Algebra 2, you may or may not have recognized that first equation as a circle centered at 0 with a radius of 2. So just a note here, the 4 being 2 squared. We'll review this later, but anyway, so I guess hopefully that was familiar to you. If not, then I apologize. So anyway, let's try to, oh no. Oh no. Running start at this. Okay. I'm gonna do my best to draw something that kind of looks like a circle. Anyway. Okay. A hard one. Can't turn the screen very well. All right. Anyway, pretend that this looks like a circle. You have an imagination? Use it. Anyway, okay. And then the second equation here is just a line graph. So I'm going to isolate y. Let's see. So we'd have x equals 2y. And then that would mean y is equal to 1/2 x. So we'll just kind of get going here. And I'm hoping that it's pretty clear that this time you're not going to have nice, fun integer answers. So at best, we could probably simplify, or not simplify, I'm sorry, but approximate what the points of intersection would be. So like this point of intersection right here is really close to the point 2, 1, but you can see that it's not right on 2, 1. So let's say it's about at approximately 1 point. Actually, I should put the approximately equal to sign in front. There we go. So this one would be at approximately, let's say 1.9, and then, I don't know, 0.8. I am just guessing, to be honest with you. And then this point right here, maybe that one would be at approximately negative 1.9 and then negative 0.8. Okay, so you can see that here, what I'm trying to demonstrate is sometimes you are left just kind of estimating when it comes to doing it by graphing. And you'll get a more exact solution when you solve algebraically. Okay, so solving this one by substitution, I do want to use this problem as an example of not always having to solve for y. I do think you'll be at a disadvantage if you think you always have to solve for y in both equations. So for example, here, you'd be left with fractions in your solution, which it's not like we can't handle that, but it's like, why would you, right? Anyway, so in this case, I don't really think that isolating y is the best move. I actually think that it's going to be a little bit of a cleaner solution if we just work with where we had isolated x. And then in that case, then we could take 2y and then replace x with it in this first equation. In that case, row 1 would then read the quantity 2y squared plus y squared equals 4. And then squaring that out, we'd be left with 4y squared plus y squared equals 4. Adding that together, you've got 5y squared equals 4. Notice we only have one variable term here, so we don't really need the zero product property. We can just go ahead and chip away at it. And then don't forget, when you square root both sides, to make sure that you include the regular square root version and then also the opposite of it. So when you square root 4/5, you'd end up with 2 over square root of 5, also known as 2 root 5 over 5. There we go. Okay. Well, now, though, we would need to figure out the x coordinates that go with it. And so you're going to see me use, you could use either equation, but I'm going to use this part here from row 2 since it's the simplest relationship between x and y. So let's figure out, what's x when y is equal to positive 2 root 5 over 5. Well, it would just be 2 times that number. And so you'd end up with, what would that be? 4 root 5 over 5. There we go. And then similarly, x when y is equal to the opposite of 2 root 5 over 5. Now, if you are using this notation, my friends, the vertical line is kind of like the right half of an absolute value mark. And then the y equals negative 2 root 5 over 5 is at the bottom of it. So almost like a subscript. Anyway, so plugging that into this relationship right here, you would end up with 2 times negative 2 root 5 over 5. There we go. So according to this piece right here, you would end up with a point of intersection at 4 root 5 over 5, and then 2 root 5 over 5. That would be probably that point of intersection on the right there. And then the second line here would turn into negative 4 root 5 over 5. Just make sure you write the x coordinate first. And then the y coordinate was negative 2 root 5 over 5. There we go. Hopefully that makes sense. You know, and if I grab my calculator and do, let's just check, 4 times the square root of 5 divided by 5. I get 1.789, or approximately 1.789, or approximately 1.8. So I guess I was a little off there. This should have been an 8, and this one an 8. And then if I double it for the x value, oops, not double it, divide it by 2 for the x value, then I get approximately 0.9. There we go. So my approximations were a little off, but not too horrible. All right, my friends, example 2 and your last example for this lesson. See if you can solve the system of equations where your first equation is y equals x cubed minus 2x squared plus x plus 3, and your second equation is y equals the opposite of x squared plus 3x plus 1.